detectors. A peak detector is a circuit that produces an output voltage equal to the positive or negative peak value of the input voltage. A positive peak detector detects the positive peak magnitude of the input, and a negative peak detector identifies the negative peak magnitude of the input. The basic blocks required for the peak detector circuit are an analog memory such as a capacitor to store the charge proportional to the peak value, a unidirectional switch such as a diode to charge the capacitor when a new peak arrives at the input, a device such as a voltage follower circuit for making the capacitor charge to the input voltage, and a switch to periodically reinitialize the output to 0. So using those 4 requirements, the peak detector circuit is shown in this figure. So it is a circuit of a positive peak detector. The capacitor CH, diode D2 and operational amplifier A1 and switch SW perform the 4 functions listed above in order. The op-amp A2 acts as a buffer. This prevents discharging of the capacitor CH. The diode D2 is preferred to be of very low leakage current. The diode D1 and resistant R avoid saturation of op-amp when a peak is detected. When the input signal Vi is greater than 0 and output V0 dash of operational amplifier A1 is positive, the diode D2 is hence forward biased and the diode D1 is reverse biased. The capacitance CH then gets charged. The feedback path provided by diode D2, op-amp A2 and resistor R maintain the virtual short between the input terminals of A1. In other words, the voltages at the inverting and non-inverting terminals of A1 are equal. Then the voltage Vi during this phase is Vi equal to V0 plus Vd2 on. The voltage waveforms for positive peak detector for a certain input signal Vi. The circuit can be reset at any time by closing the switch SW. The switch SW can be a low leakage MOSFET. Negative peak detectors can be obtained by reversing the diode connections. So this is the circuit of a peak-to-peak detector circuit. So it incorporates a positive peak detector as well as a negative peak detector. Next we will study about sample and hold circuit, S by H circuit. A sample and hold circuit samples instantaneous amplitudes of a signal voltage at any point in its waveform and holds the voltage level constant until the next sample is acquired. So this is a typical sample and hold circuit. The FET switch Q1 is included to alternately connect and disconnect the capacitor at the output of op-amp A1, and the inverse parallel connected diodes D1 and D2 are provided to prevent A1 from going into saturation when Q1 is open circuited. With the Q1 switched on, A1 and A2 acts as a single voltage follower. The capacitor voltage then precisely follows the signal input during the Q1 on time. These are all the various waveforms associated with the sample and hold circuit. Here we have signal voltage waveform, FET control voltage, and the capacitor voltage. C1 holds the sampled voltage constant until the next sampling instant, giving the step type capacitor voltage, which is the output voltage. And this graph shows the capacitor voltage versus time. So it has got two components. One is acquisition time, other one is hold time. T1 is acquisition times and T2 is the charge holding time.